Recently, Guido over on Fully Buffered did a video where he ran a AI LLM fully locally on a Pentium 4. And being that I love NetBurst so much, it kind of inspired me to see how well would it run on 4 Pentium 4s. First off, a couple things. If you haven't watched his video, go watch that first, because I'm not going to go over everything. This video is going to be extremely basic and is just kind of an addendum to that video, just to kind of see how well it can scale. If you want to learn more about the actual setup and why we have to use the software and stuff that we do to get this to work, go watch his video, because this video won't probably make much sense to you unless you do that first. And second, if you want to learn more about this machine specifically, and its history and whatnot, I'd recommend you go check out my video I made on it last year. But to give a little bit of a rundown of what this particular machine is, this is my dual Xeon 5080 system. Wait a minute, Xeon? You said this was 4 Pentium 4s. Trust me, it's basically 4 Pentium 4s. The Xeon 5080 is just the Xeon version of the famous, or rather infamous, depending on how you look at it, Pentium Extreme Edition 965, which is pretty much regarded as the best NetBurst CPU that you can get. The 965 is just a Pentium D that's, fully unlocked and overclockable. And the Pentium D is just a dual-core Pentium 4. There's nothing special about it. The cores can't even communicate directly with each other. It is quite literally just 2 Pentium 4s that just happen to be living in the same socket together. Even though we only have 2 sockets here, we effectively do have 4 Pentium 4s with hyperthreading. So yes, 8 threads. Ooh boy. These are clocked at 3.73 gigahertz on a 1066 megatransfer frontside bus, and the motherboard is an Intel S5000 PSL. Now, a couple things have changed since my original video on the system. You'll notice that I now have this very custom and very professionally made test bench for it, because frankly the motherboard was just too big to actually fit on my normal test bench, and it was kind of a massive pain to ever use it. So I came up with this, which I think it's better so far. The other major change is that in the original video, I only had 8 gigabytes of fully buffered DDR2 RAM. The reason for that was I just didn't want to spend more money on the system, and I just kind of wanted to get that video done because I had been working on it for months. Now, I had planned to get 32 gigs of RAM for this video. However, the eBay seller ended up canceling my order, but I did still manage to get 8 more gigs. So we now have 16 gigabytes of RAM on a NetBurst system. That's definitely pretty good. And given the current RAM market, 16 gigabytes is actually pretty respectable. We have a Radeon HD 6870 just because I wanted a graphics card that absolutely cannot run the AI model, so it will definitely only be running on our 2 Xeons. And we're running Windows 10 LTSC 2021. You might think you'd want to use Linux, but like I said, if you go watch his video, you'll see that the performance for some reason was worse on Linux. So we're going to stick with Windows since that seems to perform better. Dirty Cherry keyboard when clean Cherry keyboard walks in the room. Okay, so I can't quite get the system and the screen in frame for this. Just trust me that it's actually running on here. I don't know why you wouldn't trust me, but the stuff's on the screen here, just in case you don't believe me. These are 65 nanometer chips, just like the Cedar Mill CPU that he used. However, we already know that this system under full load pulls like 400 watts, and that's with it mostly just running on CPU stuff, not even with GPU. This system is ridiculous. Is it going to be any good for actually running the AI LLM? Who knows? Let's see. All right, so we're gonna open up Olama here. Also, the system is not connected to the internet, so this is definitely running fully local. You can see we got no network connection down here. And we have the Llama 3.2 3B model, same as he had. This is quite a small model. I think it's only around 3 gigabytes or something like that. So we're not taking huge advantage of our RAM here. I did look, frankly, I am not well versed in AI anything because I kind of just don't care about AI at all. I just wanted to do this to experiment and see what it could do. I couldn't really find any models that would actually fit within 16 gigabytes of RAM that were any substantially bigger than this, this is what we're going with. We're just going to do the same stuff he did. Now, a good benchmark comparison is going to be typing the same prompt that he did, which was, I believe, what's a Pentium 4? And I believe he typed that pretty similarly to this. And I'm going to do that. And our CPU is loading up. It's definitely not speedy by any means, and I wouldn't really expect it to be, you know, fast. If we can even, as long as we can get like a marginal, as long as we can get like a pretty decent speed increase. Oh, we're getting our first words popping up. That's definitely faster than his single core. Now, you'll see that up here, it says we're only using like 50% of our CPU, and you can see really only about 4 of the threads are being hit. His system was kind of doing the same, so I think that Ollama just doesn't take advantage of hyperthreading, but it's definitely working, and this definitely isn't really, and this is quite a bit faster. The word, getting like a word out about every second, or maybe like every 1.5 seconds, that's definitely a good bit faster. 0.74 tokens per second. It's not quite a perfect 4 times scale, unfortunately. You can see it took over 7 minutes to generate this. 0.74 tokens a second. Not quite a perfect 4 times scale compared to his single core. And these are clocked higher too, but there could be some, like, I don't know, Windows background process or something that was kind of screwing with this. I was kind of hoping it would be more in like the 0.80s. Be a perfect 4x scale, but I mean, that's still not, I mean, that's still quite a big increase. Now, of course, the actual thing it's printed out here is mostly complete nonsense. I mean, it gets initial clock speed for Pentium 4 processors were 1.6 to 3.8. That's correct. That's not. They went down to 1.3. It used a 0.13 micron process, which is true for Northwood, ignoring the other several revisions it had, and also that there was, 180 nanometer as well. Integrated media interface. What does that mean? L2 cache of 512K. You can see there's pieces of it that are correct, but it has no idea what it's actually talking about, and it's just hallucinating the entire thing. The Pentium 4 was known for its high clock speeds. True. And performance capabilities. No. Making it popular among gamers, developers, and those who needed a powerful CPU at the time. Sure, buddy. However, with the introduction of Intel's Core series, K10, Intel's K10 architecture. I don't know if this is the model's fault for the model being really small and it just doesn't have a lot of, data points or whatever to pull from, or if the AI just like gets stupider the slower the machine is. I feel like it's probably a combination of both. Yeah, that's well, it did the thing. It's faster. We've seen that it's faster. I don't really know what else to say on this, because I honestly, I don't care about AI like at all. It's kind of interesting. Now, this isn't the fastest this could ever run. The fastest Pentium 4 system for multi-threaded applications would be a quad-socket 604 system, which would have a lower maximum clock speed, but of course you could get 8 actual NetBurst cores on this instead of our just 4 with 8 threads. So this could be, in theory, double the speed. There's no point in, this is just a purely for fun exercise. There's literally zero practical application for this. It's just kind of neat that it can do it at all, given that this is like a 20-year-old system, and it's running like some of the newest and latest technology that there is. All right, cool. I'm gonna go work on some other videos now. Thank you for watching. See you in the next ones.